All right, we are looking at a few examples of the force of gravity and gravitational fields. So let's start up here with example 1, the forces between two masses. The Earth, here's the Earth, has a mass of 5.97 times 10 to the 24 kilograms, and the Moon, we've got the Moon at two locations, the Moon here at its perigee, which means its closest orbit to the Earth, and the Moon at its apogee, its farthest orbit from the Earth. The Moon has a mass of 7.35 times 10 to the 22 kilograms. The Moon at its perigee is 363,104 kilometers from Earth. At its apogee, it's 405,696 kilometers from the Earth. Determine the value of the equal and opposite gravitational forces between them at both locations. Okay, so what is this question asking? It's asking for the force of gravity on the Moon from the Earth, which would be equal to the force of gravity on the Earth from the Moon. It's also asking for the other relationship. When the Moon is out here at its apogee, it is going to experience a force of gravity from the Earth, but the Earth will also experience the same force of gravity from the Moon. One thing that we know is that this interaction of gravity at this location should be weaker than this interaction over here because the distance matters. The distance matters. So let's take those distances and first convert them to meters. So for example, this 405,696 kilometers would be 405,696 times 10 to the 3 meters, right? Because a kilometer is 1,000 times bigger than a meter. And similarly over here, this distance should be converted 363,104 times 10 to the 3 meters. So now we've got our distances in meters. And what equation is going to guide our thinking in this situation? Well, we're going to use Newton's law of universal gravitation. So that says that the force of gravity between two masses is equal to big G, the universal gravitational constant, times the two masses. So this will be the mass of the Earth times the mass of the Moon divided by the distance between them. So that's going to be the radius of the orbit. And don't forget to square it. Okay, so we're going to start with the perigee. The perigee meaning this situation. Okay. So the force of gravity between the Earth and the Moon at the perigee. Okay, it's going to be equal to, this is capital G, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared, times the mass of the Earth is 5.97, I'm grabbing it from right here, 5.97 times 10 to the 24 kilograms, times the mass of the Moon. Mass of the Moon is from right here, 7.35 times 10 to the 22 kilograms. And then I'm going to divide the whole thing by the radius of the orbit. So this is the distance between the Moon and the Earth at the perigee. So 363,104 times 10 to the 3 meters. Don't forget to square it. This got a little bit big, so I'm going to shrink it down here, if it'll let me do that. And then we'll punch this number into calculator, and we get, sometimes the calculator work is the hardest part on this stuff, 2.22 times 10 to the 20th. That's a big old number, newtons. Okay, so that is a huge force between the Earth and the Moon. But then again, their masses are very, very big. And you would need a huge force in order to keep the Moon in orbit anyway. So it makes sense that we would get a huge number. Let's move on to the apogee. I'm going to switch colors. So we're now in this situation. And let's grab the force of gravity at the apogee. All right, so 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. The mass of the moon, the mass of the Earth has not changed, 10 to the 24. The mass of the moon has not changed, 7.35 times 10 to the 22 kilograms. But what has changed is the distance between them. I'm now going to use that distance, 405,696 times 10 to the 3 meters. Don't forget to square it. And we end up with another very large number, 1.78 times 10 to the 20th newtons. Now, which number is larger? The force of gravity at the perigee or the apogee? Well, this number is the larger force, right? And that's because at this location, at the perigee, the two objects are closer together. So we would expect the force of gravity to be larger at the location where the objects are closer together. All right, let's try another one. This one's going to be a little bit simpler. Example 2. An astronaut on the surface of the moon experiences a gravitational field with a strength of exactly 1.6 newtons per kilogram. If two astronauts on the moon have masses of 105 kilograms and 115 kilograms, respectively, determine the forces of gravity on them. So here are our two astronauts, and they are on the surface of the moon. So all we need to do is we're now going to use equation 3 up here, which was this one. Equation 2 right here. And we're trying to solve for the force of gravity that's pulling each astronaut down. So the force of gravity, so if the gravitational field strength is the ratio of the force of gravity per unit of mass, right, then that just means that the force of gravity is the mass of an object times the gravitational field that it's in. So we could do that for both astronauts, okay? The first astronaut, force of gravity is their mass times g for the moon. Well, this astronaut's 105 kilograms. The gravitational field on the moon is 1.6 newtons per kilogram. And so we end up getting 168. And the units would be, well, we got kilograms here and kilograms there, so those cancel each other out. So we get 168 newtons. That would be the force of gravity, meaning the weight on the first astronaut. What would be the force of gravity on the second astronaut? Again, mass times gravity, mg. So this second astronaut is 115 kilograms, but still experiencing the same gravitational field. So this astronaut has a force of gravity, or a weight, of 184 newtons. That's this one. All right, and then I'm going to do example 3 in the next video.